Alright, welcome again guys to our ongoing going home revisit remake whatever we call it. I still don't know the intro. Okay, so we are now in part 8 I believe. So for now we're going to like make a side step for now. For now I'm going to talk about shaders and how to use them in love. So what is a shader? So I'm not that knowledgeable about shader, but here you go. Shaders used for advanced hardware accelerated pixel vertex manipulation, like that. So if we go to new shader, we also have here like shaders are small programs which run on the video card when drawing. Okay, so shaders are very powerful. In fact, 3D many 3D rendering stuff are done with shaders. So as you can see, the wiki has a lot of examples, has a lot of uh, thing about shaders. So we have here two different kind of shader. We have vertex shader and we have pixel shader. So here you can see that. Where is that? So where there you go. Where's the explanation? I thought it's here. Uh, so basically, so don't quote me on this, okay? So basically, pixel code or pixel shader is used per pixel. So when you run shader, the shader code is applied per pixel, okay? So vertex code is applied per vertex or vertices. So if you have a shape like 3 points like a triangle, it starts from that point, starts from this point, and from that point. Okay, so and I'm going to open Paint, and just a fair warning or just a reminder that we have here a screen, right? So when we draw stuff, so each pixel goes from top, or in this framework, love framework, from top left to top right, then it moves to the next row, and then repeat it, and then to the next row, and so on. So that's this is pixel 0 0, this is pixel 0 1, I mean 1 0, then this is pixel 2 0, and so on until we reach pixel width and height. But in shaders, we don't shaders. If we use the pixel shader, like so, there's a bunch of pixels here, right? So the shader code gets applied to every pixel in the screen at the same time. So that is very powerful. And for example, you have a vertex, like a passive vertex, like you have a vertex vertices, like three shapes, this. So it gets applied. It starts here, and then here, and then here. So it goes like something like that. Okay, so not entirely sure about it. I mean, that's how I know it. Okay, so I have already created here our asset. Okay, no, first of all, I forgot. I'm going to, let's close this. Oh no, I should have closed this. For now, we're going to make a simple transition. So we're going to use shaders for transition, right? So example, here is our screen, right? Here's our screen. Here's the title, GH, and then the menu. We want something like, we have, basically we have different kinds of transition. We have fade in, fade out, right? So like the one we use in our loading screen. Then we have side sweep transition, like from here it goes there and then sweeps, and then it covers black, black, black until it fully covers the screen. Then or from side screen swipe, like from right to left at the same time. bottom to top to bottom and bottom to the center, like that. So you can see many of those transition in Pokemon games. I think Fire Red and Leaf Green has, or Ruby and Sapphire has those. Okay, so we can do this in two ways. We can first method is no shader, like we're just going to draw a, wait, let me redraw it. So here is our screen, right? Here is our screen, and here is a rectangle object that we created outside of the view of the screen. And then per frame we want, this is pure black, okay? And then per frame we move this until the width reaches until the X reach this point. So at that point it's already covered, right? And if you want from the other way, you just put that there and then go there. Okay, so that's the first method. But another method is using shader, right? So how do we do that with shader? So we have also two ways in using for using shader. We have, example, we have, this is x equals to 0, and then this is x is equals to 1, right? So this is a normalized, when we use 0 to 1 range, this is called normalized range or normal range, which means the range is 0.0 to 1.0. okay, so, and then we have the screen, I think it's called screen coordinate, 0 to width, or 640, whatever the width is. So we will use this. So for shader we will say that if we will have a value of like value that in the shader we increase per frame, and then the value is also 0.0 to 1.0. So for example, we are in this time now, so the value will be 0.5. Then we will say in the shader code, if the coordinate is less than the value, draw that as black, else draw that normally. So there's that. So but for now, I mean, I think this is a better, I think this is the best way. We are going to use texture to do that. So as you can see here, I've already created a texture. You know what? Yeah, I did. I did not create. So we are going to use a texture that is a gradient. So gradient is from it is a smooth transition from one color to another. So we have here pure black, we have here pure white, and then it's smooth transition from black to white. And then in the shader we do like, if our current value, if the current pixel of the texture is equals or less than to the value, darken that is equals to black. Right? I don't know how to draw this explanation, right? So since, okay, wait, I'm going to show you what I mean by the texture. So let's create this, right? So we don't need this big, so let's just use 10% of that. Okay, so in Sprite we have here, or any graphics program, we have gradient tool, right? So we select the first color and the second color, and then we draw from here and then to, okay, my laptop can't handle it. Okay, so okay, that is not what I want. Oh, look at this. So yeah, here, so we have here this is the texture, right? So we have here pure black, no, and then we have here like going to white. This should be pure white, but whatever. So we have here a gray because it's from pure black it is smoothing to the second color, which is white. So that is called gradient. So let's save that in our assets. Let's create a folder there. Call this textures. And then let's say transition left to right. Actually, let's just say transition screen swipe. Wait, is that called screen swipe or screen wipe? Let's just call this for now transition, okay? Transition. I don't know. Okay, so we can close this. So remember that texture. So we have a value. We start at 0, right? We start at 0. And then in our program, we increase this 0 per frame up to 1. So let's say we are now in 0.3 value. Now, since the pixel shader code will run per pixel, it's going to check, the code will check for, hey, is this current pixel less than or equals to this 0.3? If that is true, draw that as black. Else, let's say here, else, just draw that normally. Okay, so I'll show you in code. Okay, so first let's create a directory for shaders, and then in shaders we're going to say transition.glsl. So glsl is OpenGL shader language. So that is what we are going to use. First, we need extern. Let me first save this. We have extern and then float, then dt, which means delta time, and then we have extern image texture transition. Okay, so I'm going to explain this stuff in a few minutes, in a few seconds. Vec4 effect. You have here Vec4 for color. You have image for texture. You know what? I'll just call this color and then image texture. Then Vec2 for texture coordinates. Then another Vec2 for screen coordinates. Okay, so what is this? So let us open our documentation again. So shader. Here we go, new shader. As you can see here, it's already here. Right? So if we're going to use pixel code, this is already provided by löve. So this is the function that we always need to have in that GLSL. It's like the main function, right? So vec4 means vector 4. It is a data struct or a struct which has 4 values, x, y, z, and then a or RGBA or ABCD or whatever. Then this is the name of the function. So this is important effect. This is used by löve. So the löve framework pass this stuff, these arguments here. So color is the current color that we are using. Like if we use löve.graphics.set color before the shader, I mean not before the shader, but if we use that call, it gets passed here. So remember, color has 4 values: the red, green, blue, and alpha. And then the texture is, let me show you. So let us open our for now let's just open our menu. Okay, like for example, we are now here in this draw, löve.draw. So you see this image, just the title. So that is an image, right? That is an image. So that image will be passed here. And then texture coordinates. This is only vec2 or vector 2, which means only x and y because our screen is 2D. So texture coordinates is the normalized text position 0 to 1. Then screen coordinates is not normalized. So as you can see here, we create a variable vector 4, and then text color or pixel. This is the current pixel, right? So text cell, function text cell is, I believe, where is that? Is it here? Okay, it's not here, but text cell is basically the current we're going to get the current color of the pixel, the text using the texture and the texture coordinate. So I can explain how that works, but you just have to remember that text cell is like what's the current color of the pixel with these arguments, and then just return that pixel color multiply by the color that we used. Okay, so for now let's just use that. So vec4, which is color, like let's just call this pixel is equals to text cell, then texture, then text chords. Don't forget the semicolon, then just return pixel. I will show you if we just return the pixel, okay? And then if we just return the pixel, this is what. First, let's create the shader variable. For now, let's just put this here, new shader, and then it's the shaders transition.gls. Let's run it. Okay, so it does not work because this should be slash. So here in draw, we need to wrap this whole draw with set shader, then shader, then at the end we have to close that call, so like begin and end or push and pop. So set shader, then no parameter means disable or just use the default one. So if we just use this, okay, I was wrong because we need to go to that state. So in menu, you see nothing happens, right? Nothing happens. But what if I don't know how to show you what is going to happen if we don't pass in color here, but basically we need to pass in. Okay, I remember. Okay, so example, we don't we put here, let's say let's not draw the image with pure white. Let's just say let's draw that with red. If we run this, let's say nothing happens, right? It's supposed to draw red, right? Okay, so let's remove the shader. If we remove the shader call, it will be drawn red, right? So what happens? Because as I've told you, this set color call gets passed here, right? But since we get the current color of the pixel of the image that we are in with text cell, then we just return that color without multiplying that with the color of the set color here. That means we disregard, or we just discard that. We discard the set color call, so we need to pass color here. So wait, I remove, there we go. So it should draw red again. Perfect. But what if we just we want to change that? We just say that for like, let's call green, so that will be drawn like green. See? So that is what I meant. Okay, now back to the screen swipe. So for now, so we first we need to get that image. For now, let's just put everything here, because for this part I'm just going to teach about shader, but when we are going to implement it, change our loading screen to use shader, we're going to manage, or organize this code. So for now, let's just say assets, and then textures, yeah, transition.png. Good thing I have autocomplete. Okay, so how do we do that? So as you can see here in our transition, we have this extern float and float dt and image text transitions. So the extern means we are going to get a variable or data outside of this shader code. So it's like we're going to ask for our main program for those values. So since we already uploaded this transition, how do we send that? It's just shader send the name of the extern variable. For now we have text transition, so we have to use that. So text transition and then the object, so which is transition, and then we also have dt which starts at 0, and then we want to send that per update, right? Shader send dt and then dt, and then we want to increase dt. Okay, so I should not have used dt. Let's just call this t. Let's just call this t. Okay, so let's just pass here t because there will be a variable conflict. So t will be t plus dt. Okay, now nothing happens except transition, but not use the variable. Okay, so there's a problem with one thing you have to know about shader language is that when you define a variable, when you have a variable here, right, you have to use that inside here. If you don't, you're going to get error. As mentioned here, the common error is to define but not use the variable, right? So we define those, we send the value, but we did not use them. Okay, so let us erase this. So what are we going to do? First, let's get the pixel of the transition text pixel of the text transition. So I don't know what to name this. Let's just, and by that naming variable, so the pixel of the current pixel in the transition texture. So text cell will be text transition, then text coord. Right now we will compare, since we just because that is only black to white color, we just compare any RGB value, right? So but I think it's we need to, yeah, let's try. Okay, so if pixel text transition, remember this is vector 4, so this has a R or G or B or A value. Let's get B, and if that is less than our dt, we say return what color do we want for the transition, right? For now, let's just say vec4 black, right? Else, if this is not true, then let's just return our pixel times color. So we need to define that here. So text cell, texture, and then text chords. Don't forget the semicolon. Okay, so if you run this, oops, did you see that? Again, oh, that is screen swipe. There you go. Right, so that's what we want. So if we want to change this color, right, let's say we want that to be red. There we go. But since we want black, we do this. Okay, so how do we slow that down? I think we have to we can slow that down by saying, let's say, I don't know how to slow this down. Let's say 0.25. Slow down that by 1/4. so it will be slow, like so. See, so that is a good screen swipe transition, and then we just can just increase that. So this is like, so here is just the basic basic shader. I don't know if you learned from me. So anyway, so next, for our next tutorial, for the next video, we're going to change this draw overlay to just use to just use that shader. Not the screen swipe shader, but just like a fade, like a different texture. So one thing we can do is use a Pearly Noise. So I don't have an example here of a Pearly Noise texture, but basically Pearly Noise is like those kind of fog, like this, like fog, like cloudy or smoke texture, the gray one. So that is a Pearly Noise. Like, so this is a terrible picture of that. So basically it's just like each neighboring pixel is smoothly lerp, like, I don't know what to call it, but basically, like, for example, we have this, right? So we each have a different value. So it's like this will first turn, I don't know how to explain, but I will show that we will use that for this, or we can have a random, like, for every scene we want screen swipe from left, we want screen swipe from right to left, or from top to bottom, from bottom to top, or from top and bottom to center, or a circle from center increasing in scale in radius, or vice versa, like that. So that is what we are going to do next time. Okay, so for now, let's just return. Okay, so there we go.